Before we take a look at the example on the next slide, just a quick recap that when we write a quadratic function in the form ax squared plus bx plus c, we call this the general form, where a, b, and c, these denote constants, parameters in this formula, and we're going to assume that a is not 0, so that we do indeed have a quadratic term. So a, the constant a, that's what we call the leading coefficient, and when a is positive, we get a parabola which opens upward. So this would be corresponding to an a being positive. This opens up. And on the other hand, when a is negative, now the parabola flips upside down. And in this case, it opens down. So that's what we mean by open up and down. The constant c, this tells us the value of the y-intercept. So let's say here's our axes, and this point over here, this is what we call the y-intercept, and so we can tell what this is by the value of c. And then this term with the bx, this is what we call the linear term. So let's take a look at an example to see how just by looking at the graph of a quadratic function, we can identify some properties of the coefficients, in particular the coefficients a and c. Now in this example we have 5 possible quadratic functions graphed in a through e, and based on the graph we can identify whether the constant, the leading coefficient a is going to be positive or negative, and whether the constant term c is going to be positive or negative. So remember, for the leading coefficient, if a is positive, the graph is going to open up, and if a is negative, the parabola is going to open down. So just by looking at whether the graph opens upward or downward, we can determine the sign of a. So for example, in part A, this opens up, so the leading coefficient is going to be positive. In part B, this is opening downward, so the leading coefficient is going to be negative in part B. It's going to be negative in part C because that one opens downward, and it's going to be positive in part D and negative in part E. So again, and so all we are looking at in determining the sign of the leading coefficient A is if it opens upward, like here and here. If the graph opens upward, A is going to be positive. If the graph opens downward, like in B, in E, and in C, in all of these cases, the leading coefficient is going to be negative. In considering the constant c, recall that the y-intercept occurs at the point 0c. So right, when we plug in 0 for x into the general form, that's going to be 0, that's going to be 0, and so it makes sense that the corresponding y value is c. And so in order to determine whether the constant c is positive or negative, we need to consider what is going to be the sign of the y-coordinate of the y-intercept. So for example, in part A, here's the y-intercept. Notice that it occurs below the x-axis, so this means the corresponding y-coordinate of this point is negative. So therefore, the constant term c must be negative. In part B, same idea. So y-intercept is right here. This is below the x-axis, so the y-coordinate of this point is also negative. So that means the constant term c is 0. And that's the same for part C. The y-intercept here occurs below the x-axis, so the y-coordinate of the y-intercept is going to be negative. In part D, now the y-intercept occurs right over here, and this is above the x-axis. So the y-coordinate of this point is positive. That means the constant term c for that quadratic function would have to be positive. And over here, the y-intercept is above the x-axis, so the y-coordinate of this point must be positive, and that tells us that the constant c is positive for this quadratic function as well. So to summarize, the general form, this we can gather the sign of the leading coefficient a by looking at whether the parabola opens upward or whether it opens downward. And the general form is a good, quick way we can identify the y-intercept by looking at the constant c. If the constant c is positive, we're going to have a y-intercept above the x-axis. And if the constant term is negative, we're going to have a y-intercept which occurs below the x-axis.